In this video, we are going to complete one last example of finding the area under a curve using a limiting process. This example reads, find the area of the region bounded by the graph of f of x equals 4x minus x squared and the x-axis between x equals 1 and x equals 3. Our best course of action is to begin by making a graph. Because we are interested in the region between x equals 1 and x equals 3, I use the x values 1, 2, and 3 to sketch a picture of the graph. Those points came out to be 1, 3, 3, 3, and 2, 4. So I plotted those points, and then I also shaded the area that we're looking for here under the curve. Now our next step is to find the width of each rectangle that we're going to find. So the width is b minus a over n. So our width is 3 minus 1 over n, which gives us 2 over n. Now that we have found the width of each rectangle, our next step is to find the height of each rectangle. We find the height of each rectangle by finding f of a plus b minus a over n times I. So the b minus a over n comes from the width that we just found, and a is to take into account the fact that our graph is not starting right on the y-axis. So we have to shift our first rectangle over to make it match up with the region that we're interested in finding. So when we do this, our original function was 4x minus x squared. So to substitute in, we're going to have f of a was 1 plus 2i over n. So we will have 4 times 1 plus 2i over n minus 1 plus 2i over n squared. Our next step is to simplify this here. So when we distribute the 4, we get 4 plus 8i over n minus, now we need to take care of this binomial that's squared. We can either write it down twice and multiply by distributing, or we can use the Pascal's triangle shortcut. So for the shortcut, we square the first term, then we multiply the first and the last and double it, so that would give us 4i over n, plus then we square the back term, which would be 4i squared over n squared. Continuing from here, combining like terms, we have 4 minus 1, which would give us 3. 8i minus 4i gives us 4i over n. And then distributing the negative to the 4i squared gives us negative 4i squared over n squared. Now that we have simplified our width and our height, our next step is to put them together in a sigma notation. So we're looking for the limit as n approaches infinity of the summation from I equals 1 to n of the height, so 3 plus 4i over n minus 4i squared over n squared times the width, which was 2 over n. Because 2 over n is a constant, we can factor that to the front of the sigma notation, and then we can also give each of these terms in the trinomial their own sigma notation. So it's good practice to continue writing the limit as n approaches infinity, because we have not yet taken the limit. So it'll be 2 over n times the sum from I equals 1 to n. 3 is a constant, so I can bring it to the front of its sigma notation, leaving us with 1, plus 4 over n, the sum from I equals 1 to n of I, minus 4 over n squared, the sum from I equals 1 to n of I squared. Our next step is to replace the sigma notation with the formulas that we've learned. So we have the limit as n approaches infinity of 2 over n times 3 times the sum from I equals 1 to n of 1 is just n, plus 4 over n. This formula for I is n times n plus 1 over 2. Minus 4 over n squared, the formula for I squared, is n times n plus 1 times 2n plus 1 all over 6. So at this point, before I do any multiplication, I'm going to simplify as much as I can to give myself smaller numbers and less terms to work with. So I can cancel an n here and an n here, 2 and 4. In this set, I can change the 6 to a 3 and the 4 to a 2. I can also cancel an n here and an n down here. So now I'm ready to begin my process of doing the multiplication to simplify. So we have the limit as n approaches infinity of 2 over n times 3n plus distributing the 2, we get 2n plus 2. Here I'm going to keep parentheses so I don't forget to distribute my negative. I have FOILed this out so many times that I know that it's 2n squared plus 3n plus 1, but if you didn't have that from memory, you could very easily do the multiplication to get it. Distributing the 2, we get 4n squared plus 6n plus 2, and this whole thing is over 3n. Continuing to combine like terms, we have the limit as n approaches infinity of 2 over n. 3n plus 2n is 5n plus 2. Now over here, we have a denominator of 3n, so we're going to need to multiply this by 3n over 3n so I can get that common denominator. Minus 4n squared plus 6n plus 2 over 3n. So we have the limit as n approaches infinity of 2 over n times, distributing here, 5 times 3 is 15n squared. And then we have the 2 times 3 gives us 6n over 3n. And from that, because we now have one common denominator, I can just keep going. Minus 4n squared minus 6n minus 2. And this whole thing is over the 3n. So from here, we have the limit as n approaches infinity. At this point, I can combine like terms and then distribute the 2 over n. So I have 15n squared minus 4n, so that will give me 11n squared. The 6n's cancel, minus 2 over 3n. So I have the limit as n approaches infinity of distributing 22n squared minus 4 over 3n squared. Now we'll take the limit as n approaches infinity. Because our numerator and denominator are of the same degree, n squared, we take the ratio of the leading coefficients, so our area is 22/3 square units. Throughout this process, we relied on all of the algebra that we've learned so far this year and in past years. We needed to rely on our knowledge of graphing to be able to get the shape to give us an idea of what we're looking for. So we just discovered that this green area, now the red area, is 22/3 units, which seems about right. 22/3 is a little bit more than 7. 1, 2, 3, 4, 5, 6, another like 7-ish boxes. Seems about right. Then we used our new formula to find the width and the height of our rectangles. We simplified using algebra. We then went on to use our summation formulas, which we learned this year, to continue to simplify more, using a lot of algebra in the process to simplify. And then finally, we ended by taking the limit, which we just learned to do this chapter, to discover that the area under the curve is indeed 22/3 square units.